So, welcome to today's session. This is water and wastewater treatment session, and this is actually the last session, that is 12th week session. I am Saptarshi Bose here, the PMRF research scholar from IIT Madras. As usual, we will try to solve few numerical questions and conceptual questions. So, the first question is match the following sludge treatment type with the respective sludge treatment process. So, the treatment type and treatment process are given, and at the A it's a chemical treatment, then thermal treatment, thickening, dewatering. On the other side, the first option, first one is centrifuge, second one is lime addition, then third one incineration. Okay, so we'll go for the solution and we check the answer. Right? So the correct answer is A. Here you can see, uh, just a minute. So the correct option we are getting that it's A, and the treatment, chemical treatment, is related to the lime addition. We do the sludge treatment for the using the chemicals, that is called chemical treatment for the sludge, and in that process we add lime, so it will increase the pH around 12, and we should keep the sludge for at least 2 hours. So it will destroy all the pathogens or the all the harmful pathogens we have in the sludge, as well as it will remove the toxic metal, or it will form the precipitate, hydroxide precipitate of the toxic metals. So in that way we can also remove the toxic metals from the sludge. And then this thermal treatment, this is completely related to the incineration. We incinerate the sludge. Actually, we can combust the sludge and make into carbon dioxide or some inert material. Then thickening and dewatering, it's related to centrifuge. So we do centrifuge for thickening and dewatering purpose to remove the water from the sludge. The next one is which class of the microorganisms are most active in anaerobic digestion of sludge. So whether mesophils and halophils, psychophils, thermophils, mesophils, thermophils, and the same thing like another option. You can use your chat section to write your answer. Okay. So the correct answer is C, that is mesophils and thermophils, right? Which will love the higher temperature. And then we will move to this one. Which of the following is correct sludge handling sequence? Is it a sludge stabilization, then thickening, then dewatering, then drying, or thickening will come first, then stabilization, then dewatering, something like that? Okay. So the correct option is B. That is, here you can see that first we need to thicken the sludge, we need to reduce the volume, then we have to stabilize. Maybe preferably it will be anaerobic digestion. In some case we can go for aerobic digestion or chemical stabilization. Then we need to dewater the stabilized sludge again. We need to remove the water. At last, we can go for drying beds to get the complete solidified sludge. Then the next question, that is, in the context of anaerobic digestion, which of the following statement holds good? acids are necessary to be added to make the pH neutral, or we need to add base to make the pH neutral. And also a flocculant is to be added to bring about the flocculation and the coagulation addition. So here the correct option will be option B, right? So here the correct option is B. That is here you can see. Just a minute. Yeah. So you can see that bases are required to be added to make the pH neutral. Why? Because all of you know what is the context of anaerobic digestion. In that phase, first will be there some bacteria or microorganisms which will produce acid, and then there will be metagenesis which will produce methane. But the problem is that when this acid level is too much high, because in the first step we are getting acid, right? When the acid level is too much high, then it can destroy the methane producing bacteria. So to maintain the proper pH or the pH neutral level to for the survival of the methane producing bacteria, we need to add bases, right? That is the fundamental thing behind this. We don't need to add acid because actually acids are there inside the digestion tank. Then the next one, what is the typical hydraulic retention time for a completely mixed anaerobic digestion process? What time we usually keep? So the correct answer will be A, that is 15 to 30 days. Right? So we need to keep at least 30 days for this hydraulic retention for mixed anaerobic digestion process. We'll move to the next question, that is question number 6. It is related to which of the following is used as bulking agent in composting. Okay, so the correct answer is A, that is sawdust. So we use this bulking agent to maintain the airflow or the airflow for the microorganisms there to sustain and make the compost. Right? That's why we use this bulking agent. So the next one, which of the following is a common sludge conditioning agent? Which of the following is the common sludge conditioning agent? It's A, ferric chloride, B, sulfuric acid, C, sodium hydroxide, or all of the above. Okay. So the first answer, the first question is right. Sorry, the first option is right. That is ferric chloride because we add this to reduce the water, right? And during the sludge conditioning, we can reduce water using chemicals, and one of them is ferric chloride. Then this is a numerical type question. Consider the following data from a primary settling tank. That is flow rate equals to 0.04 meter cube per second. Influent suspended solids 260 mg per liter. Removal efficiency with respect to suspended solids, that is 60%. Sludge solid concentration 6%. Specific gravity of the solids, that is 2.6765. And then specific gravity of the sludge, that is 1039 kg per meter cube. So now you have to calculate what is the volume of the sludge produced daily in meter cube per day. I'll give 3 to 4 minutes for this question, then we'll go for the solution. It's a very easy question, no formula needed, only basic concept is fine for solving this one. So we'll go for the solution. Right. No need to wait more. So the uh, so here a few data were given. First, we will try to write the data. The flow rate was given as 0.04 meter cube per second. We'll convert this into meter cube per day for our convenience. At the end, we have to calculate in meter cube per day. So that's why you are multiplying with 24 and then 60 minute to 60 second. We are getting this meter cube per day. That is 3,456 meter cube per day. This is easy, right? Then the influent suspended solids concentration was given as 260 mg per liter. So 260 gram per meter cube we can convert again into meter cube because at the end we are going for the meter cube. Then suspended solids in kg per day, that is how much suspended solids in kg per day there will be generated. So the flow is 3,456 meter cube per day. If we multiply it with this one with the concentration of the solid suspended solids in the influent flow, then we can get the suspended solids in kg per day, right? So how much water is coming and what is the concentration. So if you multiply it with this, you will get what is the suspended solids in kg per day. So I'm getting around uh, it's like 8,98,560 gram per day, right? And we can convert this into 898.56 kg per day. Now the removal efficiency was given as 60%. So the mass of solids removed in the PHT, my primary settling tank, that will be how much removed. This much is coming, totally this much is coming. It's around 898 and 60% we are getting removed. So how much is getting removed? 0.6 multiplied by 898. I'm getting around 539.136 kg per day. Now, if you know what is the sludge concentration, it was given as 6%, right? This is my the sludge solid concentration. So sludge solid concentration is given as 6%. If the solids in the sludge is 6%, then how much water is present there? That is 94%. Simple. So 94 plus 6%, I'm getting 100%. So this is the just mass balance. I am writing in the form of mass balance. Mass of sludge equals to mass of solid and mass of water, right? These are the two components of the sludge. One is solid, another one is water. So 100 kg of sludge, that is 100%, will have 6 kg of solids, that is 6% of solids, and 94 kg of water, right? This is easy to understand. Then we have this much amount of solids, right? So if 6 kg of solids produce 100 kg of sludge, right? If there is 6 kg of solids present in the sludge, so it will totally produce how much kg of solid sludge, that is 100 kg. 6 kg of solids will produce 100 kg of sludge, including 94% of water. So it's just a unitary method. For 1 kg of solids, how much sludge is getting produced? And for 500, this one, for 500 39.136 kg per day of solids, how much kg per day of solid sludge is getting produced, right? So the sludge produced with, I'm writing directly, coming from the unitary method only. For 539.136 kg of solids, I'm getting 100 by 6 into 3, 539, and it's around 8,985.6 kg solid sludge per day, right? So 8,985.6 kg solids per day. Now the volume of the sludge produced per day we have to calculate. Here it was given what is the specific gravity of the sludge, that is 1,939 kg per meter cube. So you know what is the specific gravity, right? Specific gravity was given. Sorry, it was given. Yes, it was given the specific gravity. Uh, oh, oh, oh. there is a issue. Yes. So sorry, this is not the specific gravity of the sludge. This is the density of the sludge. That's why. So please correct this. This is the density, not the specific gravity. Specific gravity was solid was 2.56. So the density of the sludge we know. So what is the density? Density is nothing but weight by volume, right? Density is nothing but weight by volume. So we know what is the weight. That is 8,985 kg. That is my weight. So I can calculate the volume. So volume of the sludge produced per day will be mass of the sludge produced per day and divided by the density of the sludge. So if you we know this density of the sludge, if you divide this weight or mass, we'll get the volume. So by that way, I'm getting it's around 8.64 meter cube per day. That is my volume of sludge produced per day. The next question, select the correct sequence of anaerobic digestion process. We'll check the solution. So the process is first hydrolysis will be there. Then the acid producing bacteria, pathogens will form the acids. Then acidogenesis, where we can get the alcohols, and after that, this acid and alcohol, all those things will be utilized in metagenesis process, and it will form the methane gas. Next question is what is the third step in the sludge handling sequence? Okay, so the correct answer is conditioning. So conditioning is the step or step in the sludge handling sequence. The next question, matching type question, types of sludge and solid concentration. This is the usual range. So you have to have this idea a little bit. So what should be the range for different type of sludge or different process mechanism of sludge? It's a primary sludge, a secondary sludge, the mechanically dewatered sludge. So the correct option is C, that is anaerobic digestion sludge. So the anaerobic digestion sludge, for that the solid concentration is around 3 to 12%. And then we'll have the primary sludge, for we are getting the solid concentration as 4 to 6%. right? And then we are getting the secondary stress, that is the third one, and which is the solution sludge concentration is nearly around 0.5 to 1.5%. And then this mechanically dewater sludge, that is we are getting around solid concentration of 15 to 40%. So in this process, we can see that therefore, if we use the mechanical dewater process, then we are getting the highest solid concentration, right? And in case of primary sludge, we are getting the solid concentration very low. The next one is again matching type question, techniques and the properties, conditioning, stabilization, dewatering, and thickening. Okay, so the correct answer is again option C here. You can see the conditioning phase. It is related to the dewaterability of the, it improves the dewaterability of the solid because after this conditioning, maybe it kind of chemical conditioning like with ferric chloride will go for the dewatering. So before that, we need to do some conditioning. So it will improve the dewaterability of the solids. Then the stabilization, it will decrease the putrescibility or the odor, the bad smell. Then we will go for the dewatering. Dewatering actually increasing in the solid concentration up to an extent where it can be handled as solids. That is our ideal thought process behind this dewatering, where we can use that or handle that as solids. Then the next one is thickening, is the increase in the solids concentration to reduce the volume. So it will increase the solid concentration and it will reduce the volume. Then the question number 13, during anaerobic digestion, if anaerobic conditions exist and the sulfate is present, then it might act as electron acceptor and form hydrogen sulfide. So which is toxic for methanogens? Is it true or false? Okay, so this is the true statement. Yes, and these act as electron acceptor and form the hydrogen sulfide, which is toxic to methanogens. Then the next question, select the correct statements regarding methanogens. They are very slow growing. They are sensitive to oxygen and toxics. They can grow easily if the pH is lower than 6. So the last option is not correct because this is lower than 6 pH, they will die basically. This is extremely harmful for them. Yes, they are very slow growing and they are sensitive to oxygen and toxic. So if there is some oxygen, because they are completely anaerobic bacteria, they will die. So, and also for toxics, they are very sensitive. And if you increase the pH, they will also die. This is a numerical type question. Consider an aeration tank of activated sludge process. Solids content by weight it's 4%. Specific gravity of the sludge solids 2.6. Density of water 1000 kg per meter cube, we all know. So the sludge from the aeration tank is put in the sludge thickener to reduce its volume. Now we have to write the density in kg per meter cube of the sludge removed from the aeration tank is. Okay, so we'll check the solution. The solution is the answer correct answer is around 1025, and the total volume we are getting, total volume can be written as water volume and solid volume. Same thing like mass balance, it's volume balance here. So you can convert this volume into this format with density. We know what is the density. Again, I am saying density equals to weight divided by volume. Weight per volume is called density. So you can write in terms of, you can write volume in terms of density and weight. So I'm converting this into total weight divided by total density. Again, water weight by water density, solid weight by solid density. So the total weight, keep it is 100%. That is, we are writing as 100. We don't know the density, total sludge density. That's why we keep it as X. Then what is the water weight or water percentage? It is 96. Suppose there is 100 kg of sludge, then the 96 kg will be from the water and 4% of the solid. So 4 kg will be from the solid, and this is the water density 1000 kg per meter cube. And even we know that we can, if there is specific gravity is given, specific gravity, how it is given, this is the density of the solid by density of water. So this is specific gravity. Specific gravity of the solids is written as density of solids divided by density of water. So if you multiply with the specific gravity with the density of water, you will get the density of solids, right? So that's why we are multiplying 2.6 with 1000, and I'm getting what is the solid density. So if you calculate, you can get X around 1025.23 kg per meter cube. Next question, select the correct statements regarding aerobic and anaerobic digestion process. Okay, so the correct answer is in right A and D in anaerobic digestion. If the supernatant is high in strength and it is recirculated to the ASP process, then it can interfere with activated sludge process, and then goal of the digestion is to reduce pathogens and reduction in VSS. So the next one, select the options which can be used as bulking agents in composting. Again, same type of question. So the correct answers are shredded papers or tires you can use. You can use the leaves or wood chips. So it will actually increase the volume. It will produce the space, vacant space volume. Through that, air can come. That's why we are using these things. But right. So, but food waste we cannot use. Right? It is not the bulking agent. It will not produce the holes for air circulation. Right? So thank you for joining today's session. And as this is the last session, I thank all of the participants, all the students for joining these live sessions throughout the whole duration of 12 weeks. And I actually enjoyed very much while teaching, while trying to solve numericals, while trying to explain the theory behind the conceptual questions. I hope all of you also enjoyed equally and you learned a lot of things, new ideas regarding water and wastewater treatment and how, as a civil engineer, as an environmental engineer, you can work. What is the core thoughts? What is the core ideas behind this environmental engineering? Particularly, what is the background of water and wastewater treatment, including theory, its applications, design of the various tanks, chambers, water treatment facilities, maybe it's filtration in your home or in the RO, or it might be a big wastewater treatment plant. I hope all of you have enjoyed, learned many things regarding this. Um, I hope it also cleared the doubts which you had during your actual lectures. Thank you. I hope we will see you again, maybe in a different course from NPTEL. Thank you. Thank you all for today's session.